EpiNerds, where science meets solutions.
So guys, today we're diving into confirmatory factor analysis, or CFA. We'll start by creating a new project first. Let's set up a directory specifically for this analysis. We'll name it CFA analysis and place it in the desired location on our computer. So let's browse a good location for it, and then we click open. So once the directory is ready, the next step is importing our data. We'll use a handy code that makes selecting the right file much easier. This code provides a user-friendly interface, letting you browse through files and ensuring you choose the correct one. So let me finish this code. The header is true, and then I click run. The data now is going to be imported successfully. With the data loaded, it's time to install the necessary packages for CFA. The packages we'll be using are readx1, Levan, and Levan plot. So let me just write the code for these packages. These packages are crucial for performing CFA. Let me type, okay, plot. Okay, I guess there's something wrong. Yeah. Then I click run again. Okay, we'll wait for the packages to be. Yeah, I need. Okay, I need to capitalize the letter P in one of the packages. No problem, I'll fix it. Then click run. So CFA is a powerful method, especially when you're assessing the validity and reliability of a questionnaire or scale. It helps determine whether the collected data fits the theoretical model you're testing. CFA is a statistical technique used to test whether data fits a specific structure or model. Think of it as a way to confirm if the relationships you expect between variables match what your data shows. I think this going to take uh, time, much more than I thought it will take. So I think I'm just gonna skip this part and we'll meet again. So now that the packages are installed, we'll need to load them by calling their libraries. After that, I will turn off the scientific notation. So I'm gonna call the libraries now, and then I will turn off the scientific notation. Turn it off, the scientific notation in the code will enhance the readability of the numbers. And by setting the scientific notation option, we ensure that numerical results are displayed in a clear and familiar format. So I will view the data. It seems that the data are good. So now I'm just gonna build my model. So I'm gonna define my model for this example. If 1 includes 4 items, if 2, 5 items, and so on. You can see that in this code. So, and so on. Once the model structure is complete, we will proceed to evaluate its fit. So I'm just gonna click run, and then I will check the fit, the measures fit. So to assess the fit, I will write the code for running CFA model and using the diagonally weighted least squares, the DWLS estimator. This estimator is particularly suitable for ordinal data. Depending on your variable types, you may need to select a different estimator. Be cautious, guys, because every type of variables has its own estimator. And by running a summary of the model, we can check the fit indices. Here you can see the chi-square, which was significant, which is in our case it was bad. The same thing can be said for the TLI and the CFI. They were unfortunately they were bad. If we see the RMCA, it was bad a little bit. It only needed a small push. Same thing for the SRMR. So finally, we can explore the correlations between latent variables using the LAVCO function. This provides insight into the relationships among the factors, which you can interpret as part of your analysis. You can also use another code or another function that gives the same results. And that's it, folks. I hope you found this walkthrough helpful. If you did, don't forget to hit like, subscribe, and the bell icon so you never miss a new tutorial. Drop your questions and your suggestions in the comments below. I'd love to hear from you. Until next time, keep analyzing and stay curious.